So when I say these two are positive, obviously the rest of the remaining will be the negative. These are all the quadrant angles. So the sum or difference with the quadrant angles are nothing but the allied angles. When you are taking the sum or difference of this 90 or 270 with any angle, then the function changes to its co-function. Whenever you are taking an allied angles in the form of 180 and 360, function will not change, only the sign may change. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to study about the allied angles. So in our previous session, we have learned some of the standard values of the standard angles of all the 6 trigonometric ratios. We have also learned the sign of all 6 trigonometric ratios in 4 different quadrants. And today we are taking that as an example and we are learning about the allied angles. So before that, let us see what are the signs of all trigonometric ratios when it comes to 4th quadrant. So when it comes to all the quadrant. So we know that, so this is 0 degree, 90 degree, 180 degree, 270 degree. So since one complete rotation is nothing but 360 degree. So after one complete rotation, again 360 comes here. So that means values of all the trigonometric ratios will be repeating after certain intervals. So therefore here 0, 90, 180, 270, 360 are also called as quadrant angles. Now any angles between them can be written as a sum of all these quadrant. Any angle between them can be written as sum or difference of all these angles. Now here in the first quadrant, all trigonometric ratios are positive. In the second quadrant, sine and cosecant are positive. In the third quadrant, tan and cot are positive. And in the fourth quadrant, cos and secant are positive. So when I say these two are positive, obviously the rest of the remaining will be the negative. Next thing is we are learning about the allied angles. If theta is any angle, then minus theta, 90 plus or minus theta, 180 plus or minus theta, 270 plus or minus theta, 360 plus or minus theta, etc. are called as allied angles. For example, 75. See, this 75 can be written as 90 minus 15. Next, 135. So 135 can be written as 180 minus 45 or can also be written as 90 plus 45. So like this, any angle which is represented in the form of sum or difference of the angles with 90, 180, 270, 360 are called as allied angles. So that means these are all the quadrant angles. So the sum or difference with the quadrant angles are nothing but the allied angles. Now when we are studying the allied angles, we need to remember these 3 properties here. The trigonometric ratios of allied angles can be remembered by the following procedure. The trigonometric ratios of angles 90 plus or minus theta and 270 plus or minus theta changes from function to its co-function. So that means here sin theta changes to cos theta and vice versa. Cos theta changes to sin theta. Similarly, tan theta changes to cot theta and cot changes to tan. Similarly, secant changes to cosecant and vice versa. Cosecant changes to secant. So here sine, cosine, tan, cotangent, secant, cosecant. So that means when you are taking the sum or difference of this 90 or 270 with any angle, then the function changes to its co-function. So sine changes to cos, cos changes to sine, tan changes to cot, cot changes to tan. Secant changes to cosecant, cosecant changes to secant. For example, if I am taking this in the form of sine 120 degree. So here sine 120 degree can be written as sine 90 plus 30 degree. So when I am writing this as sine 90 plus 30 degree, then we need to change this to cos 30 degree. So cos 30 degree. Then again after that, we need to remember the sign changes according to ASTC rule. Why? Because when I write sine 90 degree plus 30, we know that 90 is here. So any angle 90 plus 30 degree means in second quadrant. And in the second quadrant, your sine function is positive. So therefore it is plus. Whereas when you are taking 90 plus or minus theta and 270 plus or minus theta, your function changes to co-function, and hence we need to take sine in terms of cos 30. So this is how we need to remember. Only when 90 plus or minus theta and 270 plus or minus theta changes to function to its co-function. Now the same thing, the trigonometric ratios of angles 180 plus or minus theta or 360 plus or minus theta remains the same. That means they never change. For example, I will take an example of sine 330 degree. So sine 330 degree can also be written as sine 360 degree minus 30 degree. So now remember, sine 360 means obviously it comes here. So this is only 0. After one rotation, this is 360. So whenever say 360 minus theta, it comes in the fourth quadrant. And in the fourth quadrant, your sign is negative. Next rule is we need to change, since the ratios are expressed in 180 plus or minus theta or 360 plus or minus theta. Now my ratio is 360 minus theta. In such case, the ratio will be the same. So that means sine will be sine 30 degree only. So this theta is important to write the next step here, and here the function will never change. Only the sign of the function may change depending upon the ASTC rule or quadrant rule. So now let me take an examples here of all the allied angles. So sine 90 plus theta is nothing but cos theta. So when I say 90 plus theta, all comes in the second quadrant. So second quadrant. Because this is your 90 and the plus theta means this can be written as 90 plus theta, which comes in the second quadrant. So next, cos 90 plus theta means it is sin theta. Function should change according to the rule. When you are having 90 plus theta, function should change to co-function. But let us see the sign. Your cos function is negative in the second quadrant. So minus sin theta. Next we will take tan 90 plus theta. So again this is minus cot theta. Next cot 90 plus theta. Then it is minus tan theta. Next we take secant 90 plus theta. Secant is negative in the second quadrant, but it changes to co-function cosecant theta. Cosecant 90 plus theta will be equal to secant theta, but it is positive. Our cosecant is positive in the second quadrant. See now again I will take the second quadrant rule, the same function. Sine 180 minus theta. Say again this is your 180. 180 minus theta means again it comes in the second quadrant. And in the second quadrant sine is positive. So therefore this can be written as sine theta itself. Next we have cos 180 minus theta. So it is minus cos theta. Here function will not change. Whenever you are taking an allied angles in the form of 180 and 360, function will not change. Only the sign may change. But when you are taking the allied angles of 90 and 270, function also changes, sign also changes depending upon the quadrants. Now again here, tan 180 minus theta, so which is minus tan theta. Cot 180 minus theta, minus cot theta. Next, secant 180 minus theta, minus secant theta. Last is cosecant 180 minus theta, then it is plus cosecant theta because cosecant is positive in the second quadrant. So this is an example how we will analyze the signs as well as the functions when it's with 90 as well as 180. The same thing is followed whenever 90 is replaced by 270 and 180 is replaced by 360. And hence, here you need to remember that when you are taking the allied angles with the sum or difference of 90 and 270, function changes to cofunction. Also, sign may vary with the quadrants. Whereas, when you are taking the allied angles with respect to 180 and 360 degree, function remains the same. Only thing is, you have to observe the sign on which quadrant it lies so that it is positive or negative. Now for easier evaluation, we always take the allied angles with the multiples of 180 or multiples of 360 because there the function will not change, just we need to worry about the sign in the quadrants. So any angle can be expressed as multiple of 180 degree because function never changes, we need to just worry about the sign here. So let us take an example. Now, let us find the value of tan 225 degree. See, 225 degree can also be written as 270 minus 45 degree or 180 plus 45 degree. I always prefer this because whenever you are taking 270 minus 45, we need to change the function also, we need to change the sign also. So let's better use always 180 or 360 so that it is easy for the evaluation. Now here tan 180 plus 45. So 180 plus 45. So observe the quadrant. So this is the quadrant angle here. Here is your 180. Plus 45 means it comes in the third quadrant. And in the third quadrant, your tan is positive. So it's positive sign. And tan 180 plus theta is tan theta only. So it is tan 45 degree. So the value will be equal to 1. Now let me take the same value. Tan 225 can also be solved in terms of 270 minus 45. Now remember the rule. Tan 270 minus 45. So this is 270. 270 minus 45 means it comes in the third quadrant only. So here it is positive. But we are taking an allied angle with 270. So whenever you are taking an allied angle with 90 and 270, function should change. So tangents changes to cotangent. So I should take this as cot 45 degree. Now what is the value of cot 45 degree? It is 1. So whatever you take the allied angles, the final answer will be the same. So the only difference with 180 and 360 is you have very less number of steps compared to 270 and 90 degree. Now let us take few problems about the allied angles. The very first problem is cos 480. So cos 480 can be written as cos 180 into 3. So 180 into 3 is 540 minus 60 degree. So any angle can be expressed as a multiple of 180 minus or plus with some theta. So we know that 180 minus theta or 180 into 3 means again it comes here only. So here 180 or multiples of 180. So it comes here. Now when I say 180 minus theta, it comes in the second quadrant. And in the second quadrant, your cos function is negative. But since we are taking the relation with respect to cos, here 180, function will not change, function will remain same. So this can be written as 60 minus cos 60. So what is the value of cos 60? It is 1 by 2. Hence the value is minus 1 by 2. So next we will study the trigonometric ratios of minus theta. So whenever sine of minus theta, cos of minus theta, tan of minus theta, cot of minus theta, cosecant of minus theta and secant of minus theta are there. So this happens when the angle is taken in a clockwise direction. So that means, so usually we always take an angle in anti-clockwise direction. When the direction changes, then it will be written in the form of minus theta. So all these minus indicates the angle is measured in clockwise direction. So whenever angle is measured in clockwise direction, again here you have minus. So then sine of minus theta is considered as minus sine theta. Cos of minus theta remains the same. It will never change because it comes in the fourth quadrant. So if this is plus theta, then minus theta comes here. So in the fourth quadrant, your cos and secant are positive. So therefore it remains the same. Whereas the other angles becomes negative of the trigonometric functions. So tan theta becomes minus of tan theta. Cot of minus theta is minus cot theta. Cosecant of minus theta is minus cosecant theta. So the only function with plus theta or minus theta, cos and secant remain same. The other function will become minus sine theta, minus tan theta, minus cot theta as well as minus cosecant theta. Now let us take the second problem. Find the values of the following: tan minus 855 degree. So here we have tan of minus theta, which becomes minus tan theta, which means minus tan 855 degree. Now let us find the nearest multiple of tan with 180 or 360. Because tan will remains the same, we have to worry about the sign. Now this 855 can be written as tan of 180 into 5. So 180 into 5 is 900. 900 minus 45 degree. Again, since this is a multiple of 5, it comes here only. So 180. So 900 also comes here only after 5 rotation. So therefore here it is same. So since it's a multiple of 180, 180 minus 45 means it comes in the second quadrant. So now this can be written as, let us keep minus outside. Since we are taking the relation with respect to 180, tan will remain as tan only and theta is 45. But what about the sine? Since it lies in the second quadrant, this is minus tan 45 degree. And now we have minus, value of tan 45 is 1. So therefore, the final value is 1. Next problem, prove that tan 225, cot 405, tan 765 into cot 675 is equal to 0. So let us express all these with the multiples of 180 or multiples of 360. Now tan 225 can be expressed as 180 plus 45. Next we have cot 405. So this can be expressed as cot 360 plus 45. Next we have tan 765. So this can be written as tan 180 into 3. Because 180 into 3 becomes 720. If we want 65, then add 45. The last one is we have cot 675. Again, this can be written as cot 180 into 3, which is 720 minus 45. So this is how we will express. Now, this is 180 plus theta, 360 plus theta, 180 or multiples of 180 plus theta and multiples of 180 minus theta. So therefore, theta value remains the same and function remains the same. But let us decide the sign. Now 180 plus theta. So let us divide this in terms of quadrant. So this is your 0 degree or 360 degree, 90 degree, 270 degree, 180 degree. Now this is 180 plus theta. So 180 plus theta means it comes in the third quadrant. And 180 minus theta means it comes in the second quadrant. So let us decide the sign of a function. Now tan 180 plus theta. So 180 plus theta means in third quadrant tan is positive. So tan is positive and theta also remains the same. Function remains the same. Sign also does not change. Next we have cot 360 plus 45. So this is your 360 plus theta. And we know that in the first quadrant, all are positive. So therefore, this is positive. We get it as cot 45 degree. Next, plus. Tan 180 into 3 plus theta. Again, it falls on third quadrant. So third quadrant, tan is positive. So theta also remains same. The last we have cot 180 into 3 minus 45. So 180 minus theta means it lies in the second quadrant, and in the second quadrant cot is negative. So cot minus theta can be written as cot 45 degree. So now let us evaluate this. Tan 45 is also 1, cot 45 is also 1, tan 45 is 1, and cot 45 is 1 with minus. So 1 minus 1 is equal to 0. Hence, proved. Next question. Simplify cos A plus sin 270 plus A minus sin 270 minus A plus cos 180 plus A. So let us see the value and decide the quadrants here. So 0, 90, 180, 270. Now cos A remains the same. Since we are taking here relation with the 270, function also change, sign also may change. So now sin 270 plus A. So 270 plus A means it comes in the fourth quadrant, and in the fourth quadrant your sine function is negative. So this becomes cos A. Because when you are taking the relation with 270, sine should change to cos. That means a function should change to cofunction, and sine may also vary. Next we have minus 270 minus A means it comes again in the third quadrant. In the third quadrant also your sine function is negative. So therefore here we have to put minus, whereas sine changes to cos A. Next, cos 180 plus A. So here 180 plus A comes in the third quadrant, and in the third quadrant cos is negative. So this is minus cos A. So now observe here we have cos A minus cos A, minus into minus plus cos A, minus cos A. So all of them get cancels. So the value is equal to 0. Next question. Simplify tan 180 plus A, secant 180 plus A, cosecant 90 plus A whole divided by secant 360 minus A, cot 90 plus A. So let us write the quadrants. So this is 0 or 360, 90, 180, 270. So this will be 90 minus theta, 90 plus theta. 180 minus theta, 180 plus theta. 270 minus theta, 270 plus theta. 360 plus theta, 360 minus theta. So next we will take tan 180 plus A. So this is 180 plus A, which comes in the third quadrant. And in the third quadrant, tan is positive and function also do not change. So it is tan A. Next we have secant 180 plus A. Secant is negative in third quadrant. So we can write it as minus secant A. Next, cosecant 90 plus A. So 90 plus A means it lies in the second quadrant. And in the second quadrant, cosecant is positive. But since we are using with 90, cosecant should change to secant A. Next, whole divided by secant 360 minus A. So this is your 360. So 360 minus A means it comes in the fourth quadrant. In the fourth quadrant, secant is positive. Secant also remains the same. So secant A. Next we have cot 90 plus A. 90 plus A is again second quadrant, and in the second quadrant cot is negative and cot should change to tan. So tan A. So we can cancel secant A, tan A, minus get cancels. So the final value is secant A. Next question. Find the value of theta such that 0 degree theta less than 360 degree if sine theta is equal to 1 by root 2. So we need to find out the solutions for theta. Means what are the angles which lies between 0 to 360. That means we need to find the answers from the first 4 quadrant itself, so that sine theta is equal to 1 by root 2. Now let us take here 0, 90, 180, 270. So remember here we need to take the answer between 0 to 360 degree. Now given sine theta is equal to 1 by root 2. So here sine is positive. So by looking at the value we can say it is positive. Where sine is positive? In the first quadrant and in the second quadrant. So any angle in the first quadrant can be written in the form of theta. Any angle in the second quadrant can be written in the form of 180 minus theta. Any angle in the third quadrant can be written as 180 plus theta. And fourth quadrant angle can be written as 360 minus theta. So this can also be written as 360 plus theta. So remember these rules when you are finding the solution for theta. Now here sine is positive. So this implies solution lies in first and second quadrant. Now for what values we will get 1 by root 2? So remember the standard angle. Sine 1 by root 2 is for 45 degree. That means sine 45 degree is 1 by root 2. So therefore here theta is equal to 45 degree. And this implies theta is 45 degree in first quadrant. But second quadrant we will write it as 180 minus theta. So therefore the angles are theta and 180 minus theta. So this implies the angles are 45 degree and 180 minus 45 degree. So this implies the angles are 45 degree and 135 degree. So what does it mean? Sine 45 degree is also 1 by root 2. Sine 135 degree is also 1 by root 2. Because see, 135 can be expressed as 180 minus 45, which is same as sine 45. So therefore, sine theta is equal to 1 by root 2 for theta is equal to 45 and theta is equal to 135. Next question. Find the value of theta such that theta lies between 0 degree to 360 degree if 2 sine theta is equal to root 3 tan theta. So first let us evaluate this. 2 sine theta is equal to root 3. Tan theta can be written as sine theta by cos theta. So we can cancel sine on both sides, shift cos and 2, then we will get cos theta is equal to root 3 by 2. Now the value is positive, so therefore is cos theta is positive in first and fourth quadrant. So remember your ASTC rule, cos is positive in first and fourth quadrant. So therefore, how a fourth quadrant angle is taken? 360 minus theta, and how an angle in the first quadrant is taken? Theta. So therefore, what happens? This implies the solutions are theta and 360 minus theta. Now for which angles of cos theta will be equal to root 3 by 2? For 30 degree, that is cos 30 degree is root 3 by 2. So therefore your theta is 30 degree, and hence here the solutions are 30 degree and 360 minus 30 degree. So this implies the values are 30 degree and 330 degree. So therefore cos theta is equal to root 3 by 2 for theta is equal to 30 and theta is equal to 330, because 330 can be expressed as 360 minus 30, which is same as cos 30 itself, and hence you will get two solutions between 0 to 360 for any angles of theta for all 6 trigonometric functions. So thus we have discussed about the allied angle property of all the 6 trigonometric functions in this session. I'll meet you in the next session with the new concept. Until then, keep watching, keep learning and keep exploring. Thank you.